Once again, warm-up number 23 is on the screen for number 1, part A and B. It says simplify to lowest terms. Make sure you factor each number first. Part A reads 18 over 27. Part B is 15x to the 4th over 6x to the 4th minus 30x cubed. For numbers 2 and 3, it says factor. Number 2 reads x squared plus 2x minus 15. And 3 is x cubed plus 5x squared plus 3 minus x. For number 4, it says solve for y and evaluate with a domain -3, 0, and 0.5. And they give us the equation for number 4, 4x minus 2y equals 2. And number 5, it says add or subtract, and they give us 2/15 plus 1/20. All right, copy that in. I'll give you some time for that. Ready, go. All right, so for the sake of time, let me go over, since it's Monday, let me go over the warm-up really quick. Number 1 says simplify to lowest terms, and it says to factor each number first. So for the first one, 1A, we have 18 over 27, and I remember when I first started with this one, I said, what would be a GCF for these two numbers? Of course, we're thinking 9, is that correct? So 9 and 9. So 9 times 2 is 18, and 9 times 3 is 27. Now, why do we need to do that? Because now we can see that 9 over 9 is a giant 1, and that leaves us with 2/3. And you're like, Mr. Q, I got the same thing without doing all that. Okay, I got you. Well, you need to do all that for this one. So 15, if we factor 15, is the same as writing 3 times 5. Is that correct? And x to the 4th is the same as writing x times x times x times x over. Now we have a binomial, so then I'm thinking GCF. What's GCF for 6x to the 4th and 30x cubed? Well, they both can be divided by 6. And they both have at least x cubed, so that's 6x cubed. That leaves us with x minus 5. So far so good, yes? Now check this out. I'm going to factor this one more, the 6x cubed. So what would be factors of 6x cubed? The factors of 6 are 2 times 3, and x cubed would be x times x times x. So I replace this with this. So I'm going to scratch this out. I'm going to focus with this and the numerator. Now, by looking at it, do you see any giant ones? Yeah, the 3 over 3, that's a giant 1, yes. What else? X over x, x over x, and x over x. All right, your brain might want to do this. 5 over 5, but we can't, because this is a subtraction. We can only do that when there's complete multiplication. Notice here we have multiplication, and also here, yes? Okay, so we can't do that there. So what does that leave us with the numerator? 5 times x, that's 5x. How about the denominator? We have a 2 and x minus 5. Number 2. So for number 2, we know that we check for standard form, right? And then we check for GCF. There is none. So my leading coefficient is 1 times -15 is -15. The middle term is 2. So factors of -15 that add to give us 2, and that is -3 times 5. What is -3 times 5? -15. -3 plus 5 is 2. From there we bring down the first term and the last term, and then we write those in the middle, we group and all this and that, so at the end we get x minus 3, x plus 5. And have you got that by yourself? Yeah, some of you? Yes, good. Number 3. Now for number 3, we need to check to see if it's standard form. Is it in standard form? No, so then I rewrite x cubed plus 3x squared minus x plus 3. Now, why am I bringing this up? Because some of you on the pop part say you skipped step 1. Then all of a sudden you did like a bunch of stuff and it looked like it was on fire. I'm like, what's going on? Anyways, group. GCF here is x squared. We're left with x plus 3. Plus, GCF here is negative 1. We're left with x minus 3. Now, since this is not exactly like this, that's where we're going to stop. Can't factor anymore. Number 4. Let me zoom in for number 4. And it says to solve for y first, and then we're going to evaluate given a domain. So, let's see. So that means I need to subtract 4x, subtract 4x to each side. We're left with negative 2y equals negative 4x plus 2. My last step, divide by negative 2, divide by negative 2. So that leaves me with y equals 2x minus 1. And if you got that, okay, good. Let me zoom out. Alright, let me write it over here. Y equals 2x minus 1. Alright, I'm going to start out with the domain, which is all x values. What do they give me? Negative 3, 0, and 1/2. I wrote it as a fraction, it's the same thing. And I need to find what? The y values. What is the name of that? Range. I'm going to write it there because I need you guys to make sure you think of the terminology because we're about to get into the graphing portion of the school year. So here we go. So I take negative 3 and I substitute that here. So negative 3 times 2, that's what? Negative 6 minus 1, that's negative 7. Next value, 0. What is 0 times 2? 0 minus 1, negative 1. And last but not least, what is half of 2? 1 minus 1, that's 0. Okay? And last but not least, number 5. Here we go. For number 5, I'm going to rewrite it. So we got 2 in the numerator plus 1 in the numerator. Then question. We need a common denominator, but I showed you to find first the GCF. What's GCF between 15 and 20? 5. So 5 times 3 and 5 times 4. So question, what does this denominator need that the first one has? A 3, a 3. What does the second denominator have that this one has? Needs 4 and 4. Therefore, 4 times 2 is 8 over 4 times 5 is 20 times 3, that's 60. 3 times 1 is 3, and this is 60 as well. Common denominator 60, and then we focus on the numerators. That's 11. We good? Yeah? Alright, so before I give you the agenda, I was thinking over the weekend, I was really busy looking at my notes. I was trying to make sure I was ready for you guys. And every year, as I take notes for the following year, I noticed that, and I asked myself, so your beautiful, awesome students are going to need to know the properties, the identities that you gave them. Will they be ready on Monday for a pop party on only those itty-bitty 5 identities that they needed to memorize? Because they're going to need them. What if you help them out and double up the points from the previous party just for those 5 little identities? I thought. You know what I'm saying? And I said, well, no, but let's do another session on identities to make sure they're ready. My goodness. So that's why on our agenda we have warm-up number 23, Michael Jordan. Polynomial identities again. And today, your only task tonight is to study them, to make sure you got the 5 little itty-bitty identities But you're going to write 6 of them yourself. You're going to make up 6 of them, and I'll give you those instructions at the end. Okay? Copy that really quick. All right, here we go. For those of you watching online, this is a code for Nearpod, DEJCL. Now, since we don't have any play sheet or any page number, there's just so if you want to follow along using Nearpod, the presentation, there it is. There was no home play over the weekend. I said to act like tomatoes and catch up if you needed anything to be caught up with, like your identities. And tonight it's only making up 6 identities on your own. So here we go. Our objective for today, I can master polynomial identities. I can master polynomial identity. Do we know what polynomials are? We don't need a fair model, do we? No? Okay. Alright, but we do need these identities, right? Copy those, please. Parentheses x plus y, those parentheses squared equals 2, x squared plus 2xy plus y squared. The second one, parentheses x minus y, close parentheses, squared, equals 2x squared minus 2xy plus y squared. The third one, parentheses x plus y, close parentheses, open parentheses, x minus y, close parentheses, equals x squared minus y squared. The fourth one, x cubed minus y cubed equals to parentheses x minus y, close parentheses, open parentheses, x squared plus xy plus y squared, close parentheses. And the fifth one, x cubed plus y cubed equals to parentheses, x plus y, close parentheses, open parentheses, x squared minus xy plus y squared. As you're writing these down, I mentioned when we first covered the first 3 that these were known as perfect square trinomials. From there, this third one, I said this is known as difference. Now here's some terminology. Why difference, Mr. Q? Because, look up, because this is a subtraction. That's what difference means. Of, subtraction of what? Squares. Why squares, Mr. Q? Because this one is a square and this one is a square. Okay. So, if this one is known as difference of squares, what would be the name of this one right here? Yeah, difference of what? Cubes. Yeah, that is correct. And the last one, instead of being difference, now it's a addition of cubes, which is sum. That's what we call a sum of cubes. Now, put a little asterisk on the difference of squares, asterisk, a heart, We're going to focus on that one more today. And on the difference of cubes, asterisk, a heart, there it is. Those 2 we're going to really hammer out today to make sure we got those, okay? However, you're supposed to memorize all 5 of them, right? Yes, Mr. Q. So get home tonight, say, gather around, people, let's make it up math family night. Let's go. Get some nachos and, you know. All right? We got those, yes? All right. There's only 5 of them, guys, because what if you have some more? You know what I'm saying? They're going to start building up. So with that said, what I'm going to do right now, I'm going to get your noodle ready for me to go through the practice of these, but I want you guys to see things with my goggles, okay, my math goggles, okay? So I'm going to do like a David Blaine Chris Angel type of thing to get your brain ready, okay? We already covered this one. We did this one and this one. Remember, identity and such like that, yes? So before we get to the practice, I want to make sure we understand what we're talking about in regards to squares and cubes. All right? You're just paying attention, writing your pencil down, look up to the screen. First, squares. It's a geometric figure, yes? A geometric figure with how many dimensions? 2. 2 dimensions. Height and length. That's why whenever you did some of the work in your previous classes, they asked you, well, it's in units or feet squared. The little 2 indicates how many dimensions are being multiplied. How many are being multiplied here? 2. Cubes are, let's see, 1 dimension, 2 dimensions, and 3 dimensions. That's why whenever you get the volume, they always ask you to write it in cubes with a little 3, because how many dimensions? 3. Good recap, yes? And you're like, oh, I didn't even know that, Mr. Q. Well, there you go. 1, 2, and 3. So if I told you to find me the first squared number, you would do this, okay? So if I start with the number 1 here, what would this side measure? Let me repeat that again. If this is 1, that means this is also 1, because it's a square. So I would write 1 squared. What is 1 times 1? 1. So the area here would be 1. Let's look at it in cubes. 1 times 1 times 1. So that would be 1 to the 3rd power, which is 1. You're like, we get the same answer? Yes. This is the only number. Number 1 is the only number that is the same for all dimensions. So it's known as a square. It's known as a cube. However, from here it differs. What is 2 squared? 4. What is 2 cubed? 2 times 2 is 4 times 2 is 8. Next one, 3 squared. 9. How about 3 cubed? 27, because 3 times 3 is 9, times 3 is 27. About 4 squared. 16. How about 4 cubed? 4 times 4 is 16, times 4, that's 64, and so on and so forth. Yes? How about a big number? A big number here. Let's see. Help me with that big number. Lewis. 100. What do you do to get that? 10 times 10. Okay. How about a big number over here? Brooke. One. Oh, you mean here? 5 cubed, okay. So what is 5 cubed? Close. 5 times 5 times 5. 25 times 5. That gives us 125. Is everybody following so far? Yes? So if I was to ask you to give me a squared number, do you know how to get that squared number? Yes. Okay, share a squared number with your neighbor, please. A squared number. What would be a number that you are thinking about? You got your number? Yes? You got your number? All right, help us out, please. Brianna, what would be a squared number? 49. Is 49 a squared number? Yes. And she got it from 7 times 7. Okay. How about a cube number? Help us out, Noor. Did I catch you off guard? Okay, sorry. A cube number, Noor. Or let me help you. What is 10 cubed? 1,000. Did everybody know how I got 1,000? Yes, by multiplying 10 times 10 times 10. Okay. Now, we know how to find square numbers. We know how to find cube numbers. Okay. However, what if I asked you to factor these to their original number? What do I need to do to 9? I need to do the opposite of squaring the 3. I do what? Square root. What is square root of 9? That is 3. What is square root of 100? That is 10. Or in other words, what number times itself 2 times gives me 9? That's 3. What number times itself 2 times gives us 100? That's 10. All right, Mr. Q, I get that. But how do I do this number? Well, this one is cube root with a little index right there. What does that mean? What number times itself 3 times? That's what that 3 means. Times itself 3 times gives us 8. The number is 2. Look at this one. Cube root of 64 is the same as what number times itself 3 times gives us 64? So that'll be 4. 4 times 4 is 16 times 4 is 64. How are we doing up to right there? Good? Good review? Yeah? So we know what square numbers are, we know what cube numbers are, and we know how to go the opposite direction to get the root of each. Okay. Now that we're there, do some practice. Yes, we're going to start slow. Then we're going to get you guys on the bike. Right now you're walking down the street, copy this one, and you bump into this one, factor completely. Example Q, we got x squared minus 1. Alright? So, look up. From afar, the first thing you notice is a what? Subtraction. That means it's a difference, yes? What else do you notice? A square. So that means that this could be a difference of squares. How can I check, Mr. Q? Well, let me see. Can I take the square root of that one? Yes, that gives me x times x. Can I take the square root of 1? What is square root of 1? Yeah, 1 and 1. So that means that does seem like a difference of squares. So whenever you can take a square root of the first and the last and it's a difference, that means this is a plus and this is a minus. And that would be that one. Copy that, please. Do another one. X squared minus 9. How would we write that? Tell your neighbor, how would you write that? Let's see, what'd you get, Drina? X what? X plus 3 and X minus 3. Hands, you got that? Okay, let's do another one. And check and make sure. Is it a difference? Yes. Can you take the square root of this? Yes. How about this? Yes. Okay. Example, supercube. X squared minus 49. check with the neighbor, see what would they write for that one. All right, what'd you get for this one, Valerie? X plus 7, X minus 7, hands if you got that. Okay, now don't copy this one. X squared, actually let me change the variable. Q squared minus 100. So you know the factors for that one. Yeah, Q plus 10, Q minus 10. Hands if you got that. Okay, we good? Crank it up a little bit. Copy this one. Example method Q. 25x squared minus 1. Yeah, try and see if you can find me the factors for this one by yourself. All right. Talk it over your neighbor, see if they got the same thing. All right, let's see what you get for this one, Vianney. What is it? I can't hear. You didn't do this one? Okay. So let me help you guys out. Can we take the square root of this one? Yeah, what is square root of 25? 5 and 5. Square root of x squared is x and x. Okay. Can we take the square root of this one? Yes, that's 1 and 1. So this is plus, minus. Hands, have you got that? Okay. All right. Let's do another one. Here we go. Example super duper cute. 36x squared minus 81. Well, let's first do the first step and see what we did. All right, share with your neighbor, see what you got for that one. All right. So let's see, Juliana, what'd you get? Yes, Andy? 9. Hands if you got that. Okay, and then 6x minus 9. All right. So far so good. Now we know the process, yes. Now in case some of you are still thinking about it, it's still a difference. It's a square, and how do we check to see if these numbers are squares? By see if they can take the square root. Okay. Now, Sky would say, Mr. Q, do we simplify it? You know, some of you are like, what do you mean? Well, what she means is the following. Watch. What is the one thing I asked you to do with polynomials? Standard form, yes. What else? Well, step 2. GCF. So question. Now, I'm going to leave that on the side for this. That's fine so far. Question. What is GCF between 36 and 81? 9. All right, so 36 divided by 9, that's 4x squared. Minus, what is 81 divided by 9? 9. Question, can I take the square root of this one and this one? Yeah, so that means this is the difference of squares. This is 2x, this is 3. 2x, that's 3. One of them's positive, one of them's negative. And don't forget the BFF. These are my factors. Copy that, please, and then I'm going to show you how to go from this one. All right? So this is our answer. These are my factors. So if we start this way, we're good. If we start this way, we're still good because we can continue simplifying. So look up to the screen. Question. What's GCF for these two? 3, and that leaves us with 2x plus 3. Times. What is GCF for these two? 3. That leaves us with 2x minus 3. Yes? Okay. Now check this out. There's multiplication here, here, and here. That means I can move these around, can't I? You're like, what does that mean, Mr. Q? Yeah, if I had 2 times 3 times 5 is the same as 5 times 2 times 3. I can move stuff around and it gives me the same product. Is that correct? So that means I can move these around and write 3 times 3 times 2x plus 3 times 2x minus 3. And let's see, what is 3 times 3? 9. And what else do I have? 2x plus 3 and 2x minus 3. Do I get the same thing? Yeah, copy that one, please. Like that, you have at least the other way of doing it in case you don't do the GCF at the beginning. Copy that. Now check this out. Some of you are saying, well, I like this one better and I can do this one a lot faster. Some of you said, well, I already went this way, I just do the next step, but it seems a lot of work. Well, I'm showing you both, guys, because what if I give you big numbers here that you can't really think about the GCF? What would your next step be? Then do this first and then do, with the smaller numbers, the GCF. Does that make sense? Such as this one. Copy this one. Example, Michael, George, and Q. Factor completely. We have 64x squared minus 144. I'll give you some time for that one to see how you do with that one. Ready, go. Alright, before I go over it, share with your neighbors, see if you got something like them, or maybe you got stuck doing like the factor tree or something. Talk it over with your neighbors, see where you're at so far. Alright, so let's say I called Jessica and I said, Jessica, what was your GCF? She would say, I don't know, Mr. Q, I just did the pattern like you showed me. Because it's too much to think about, yes, some of you? So that means it's still a difference, it's still a square, so can I take the square root of this one? Yeah. That is what? 8x and 8x. So far so good, yes? What is square root of the second term? 12 and 12. That means one is positive, the other one is negative. Okay. Now, since these are smaller numbers, can I find the GCF? What would that be? 4. That leaves me with 2x plus 3 times, what is GCF for this? 4, and that leaves me with 2x minus 3. So that means I can move stuff around, so that would be 4 times 2x plus 3 times 2x minus 3. So that leaves me with 16, 2x plus 3, 2x minus 3. And these are my factors. Hands, have you got that? Yeah, some of you got the 16 at the beginning. You divided out the 16 and then you went to work from there. Alright? Alright, so far how are we doing with difference of squares? One being the lowest, one being the highest. We got 5 fours, 4 4 5, 4.5, okay, 3, okay. So, we just need practice, yeah? How about we crank it up a little bit, yeah? Ready? Here we go. On fire. Shazam Q. 9x squared y squared minus 25z squared. Very similar. Should be able to see it. Yes, I'm doing a David Blaine right now. Boom. Singing the math vibes. Should be able to write your two factors. Got it? All right. Share with your neighbor, see what they got. All right, let's see. What did you get for this one? Miguel. What's that? Oh, okay. Help him out, Carlos. 3. XY plus 5Z. And then the other one is 3XY minus 5Z. Hands if you got that. Let's go. Let's go. Tweezy. Right? Alright. We good with squares, yes? Let's crank it up now with cubes. Copy this one, example 2. Factor completely. X cubed minus 1. So, just for the sake of looking at my identities, it's not this one because this is squares, squares, squares. That means now we're here. So this is a difference of what? By the looks of it, cube. So it might be this one. Let me double check. Can I take the cube root of that one? Yeah, what does that leave me with? X. Can I take the cube root of 1? Yes. What number times itself 3 times gives me 1? 1. Okay. And it's a difference. So this is a difference of cubes. That means I'm going to use this one. However, this one only has X and Y. What do I have here? X and 1. That means this is still my X. However, this instead of Y, I'm going to use what? 1. That is correct. So here, I need to do this on this side. So that means I'm going to open a small parentheses with a minus and a long parentheses with 2 pluses. So let's see. What do I have? I have first X minus Y. Minus Y. So what do I write here? What is X? It's still X, so I just write X. And instead of Y, what am I going to write? 1. That is correct. Next, what do I write? X squared. Okay, that goes right here. It's still X and X squared. Okay. Then, X times Y. So X times Y. But what do we have for Y now? 1. And lastly, we have what? Y squared. So that's 1 squared. And at this point, all we have to do is simplify. Here we go. X minus 1. X squared. What is X times 1? That is X. And what is 1 times 1? 1. These are my factors. Do another one right here. X cubed minus 8. Let's see, I'll give you some time so that you can follow that process, see how you do. Copy and go. Alright, I'm not going to have you share with your neighbor. Let me go over this to make sure we got it. By the looks of it, Mr. Q, it's a difference of cubes. Well, let me check. Is there a cube root of X cubed? Yeah, that's X. Can I take the cube root of 8? Yeah, that number is 2. So that means I have my X and I have my y. Now instead of y, I'm going to write the number what? 2. So, from here, small parentheses with a subtraction, long parentheses with 2 pluses. Alright? So then I start with x and y. So that means x and y is my 2. Next, x squared, because now there's my x, there it is. Then x times y, and what is y now? 2. And at the end, y squared, so that's 2 squared. Simplify, so this is x minus 2, x squared, plus 2x, plus 4. These are my factors. Right, the subtraction sign right here isn't a negative sign. This is part of the identity. So that's why you don't use negative whatever. Show me your fingers, how come you are so far? Okay, 5, 4, 5, 4. Okay, let's crank it up a little bit. Copy this one. 27x cubed minus 1. We'll do this one together. Alright, first thing, what do we do to check? Well, there's a difference, yes. And then, see if we can take the cube root of the first term. What is cube root of 27? 3. Cube root of x cubed? X. What is cube root of 1? 1, okay. So that means that whenever I see an x, what am I going to write? Here on the pattern, instead of x, what am I going to write? 3x. And instead of y, what am I going to write? A 1. Okay. So, small parentheses with a subtraction, long parentheses with 1 plus and another plus. Okay. So, what goes here? X, but since now it has a 3, I'm going to write 3x. And over here, the 1. So before I continue, tell your neighbor what to write here. Yeah, 3x to the second, and then we write 3x times y, which is 1, and then at the end, 1 squared. So, simplify this, 3x minus 1. 3x times 3x is 9x squared. 1 times 3x, that's 3x, and 1 squared is 1. And these are my factors. So many things I'll come to you with these. 4, 5, 4, 5. So basically that's the difference of squares and difference of cubes, yes. The 9x what? Yeah, because we do 3x times 3x, which is 3 times 3 is 9, x times x is x squared. Yeah. All right, so for tonight, you need to come up with 6 identities, 3 of each, 3 difference of squares, and 3 difference of cubes. So for example, Andy's going to help me out really quick. Andy, let me start you out. Difference, difference. Can you give me a variable squared? A squared, very good. Andy squared, okay? And give me a square number. 4. Is this a difference of squares? Yes. You need to make 3 of them up, not that one. You need to make up your own. How about cubes? I'm going to start off with a number, 8 x cubed. Who can give me a cube number there? What do you think, Philip?
125.
125. This is a difference of cubes. You need to make up your own 3 of each for tonight, okay? And then you write them out with a pattern, yes? All right, and we'll stop right there, guys. And for those of you online, once again, make sure you stay on top of your stuff. And I'll see you guys tomorrow. Bye.